Hello viewers, in today's class we are going to discuss one important and interesting definite integral, right? And here we have to find the value of this integral from 0 to infinity, and the integrand is 4 raised to minus 4x square, right? So let us see how easily we can solve this integral. So let us take this integral as I, right? And before proceeding further, let us quickly see an important result from calculus, right? Now see, we know that e raised to a log of f of x is equal to f of x, right? This is a very famous result in calculus, and if we replace f of x by some number, say a, then e raised to natural log of a is equal to a, right? So here, in order to solve this integral, we'll utilize this important result. So here in the integrand we have this 4, right? So we'll write 4 as e raised to a natural log of 4, right? Okay, so we'll substitute 4 is equal to e raised to natural log of 4. So now this integral becomes 0 to infinity. Now we can replace this 4 by e raised to natural log of 4. So we have ln 4, and here we have the power minus 4x square, and this is dx, right? Okay, now using the laws of exponents, what we will do, will multiply this log of 4 by minus 4x square. So we can now write minus 4x square in front of natural log of 4, and we have now this integral, right? So using this result, we have transformed this integral from this integral to this one, right? Okay, now let us make use of the method of substitution. So now we can write this integral I as 0 to infinity, and here we can write minus, and 4x square log of 4 can be written as 2x and square root of log of 4, and here we can write the square, right? So we have written 4x square natural log of 4 as the square of 2x times square root of log of 4, right? So when we make the square of this term, we'll get this one, right? Now let us apply the method of substitution, and let us put t is equal to 2x times square root of log of 4, right? So we'll make this substitution here, and we can change the limits accordingly. So obviously when x is 0, then the value of t is also 0, and when x is infinity, then obviously t is also equal to infinity, right? Okay, now let us differentiate this t with respect to x. So we have dt over dx is equal to 2 times square root of log of 4, and the derivative of x with respect to x is simply 1, right? So now dx can be replaced by dt divided by 2 times square root of log of 4, right? So now we can write this integral I in terms of t. So we have 0 to infinity, and we have e raised to minus c 2x times square root of log of 4 is t. So we have here simply t square, right? And for dx, we can now write dt divided by 2 times square root of log of 4, right? So now we can see that 2 times the square root of natural log of 4 is a constant. So we can take it out outside the integral. So we have 2 square root of log of 4. And here we have 0 to infinity and e raised to minus t square dt, right? And we know that this is a very famous integral, and here we are not going to solve this one, and we'll make use of a direct result for this integral. So from the theory of beta gamma functions, we know that the integral 0 to infinity e raised to minus t square dt is equal to square root of pi divided by 2, right? So here I will make the direct application of this result. So we have now I is equal to 1 over 2 times log of 4, and here we have root pi over 2. So simplifying this expression, we have root pi divided by 4 times square root of log of 4, which can also be written as 1 over 4. And here we have a square root of pi over log of 4, right? We can also express this result as a square root of pi, and we can take this 4 inside the square root sign. So we can write it as 16 because the square root of 16 is 4, and here a log of 4 can be written as log of 2 square, that is 2 log 2. So here we have 2 log of 2, right? This is the natural log, so we have a square root of pi divided by 32 times the natural log of 2, right? So here's the value of this integral is equal to square root of pi divided by 32 times the natural log of 2.